Hello, everybody, and welcome to the October 9th, 2025 meeting of the Howard Astronomical League. We have a pretty cool speaker today and lots of stuff to cover. I'm just realizing pretty soon I'm going to have to change the logo to say 26 years. So I'll just jump into our agenda if my computer will behave. So the agenda for tonight, we'll do in some introductions. There's a few announcements about upcoming events, recent events, and some other exciting things like Holiday Star Party and HAL on Maryland Public Television. And then Guy Brandenburg, the president of National Capital Astronomers, is here with all sorts of goodies. We have all sorts of show and tell in the room. But we'll see how we can, move the camera around, when we get to that point. And then we'll do our regular sections on what's going on in the sky. Jim Tomney is actually here in the room, and Wayne with his news, and then we'll go over some images and whatnot. So first, introductions. Okay, we sort of have light over there, but is there anybody new that would like to, that's new to HAL or just new in general that would like to say hi online or in the room?
I guess I'm kind of new. It's the first meeting I've come to.
Okay, who are you?
Well, I live in Clarksville and I started building my first telescope in 9th grade and ground it too far so where I would have to reverse it. And then I just gave up in high school and lots of things going on. So I saw a member of HAL and I've gone to a couple of Alpha Ridge things. But so I'm just starting to get into meetings.
Well, this is a perfect meeting then, and I think you'll see that. I mean, if you've been to a couple of things already, you'll see that we got a lot of people who like to share, but maybe too much. But it's a great place to pick up information on amateur astronomy. So welcome.
Thank you.
Anybody else want to say hi or? Okay. Anybody online? All right, we'll move on then. So, star parties that are coming up and recent events. So we just had a public star party on the 4th, and it was kind of a blockbuster. I'll talk about it in a second. We had like 3 impromptus this month, so thank you to Ernie and Jose and Wayne for opening up the park. Between last month and this month, we also attended the Astronomy Festival on the National Mall. You can't really see it too well, but that's me and my 11-inch Schmidt Cassegrain. It was a touch and go night with the clouds and whatnot, but it actually cleared up, and the seeing was surprisingly good to view Saturn. Saturn showed up over these trees over here, and so I had quite a like 4 hours of a line like this or longer at the scope, and I got to meet lots of people from the other booths and traded cards, and I think I may have found a speaker or two coming up. So anyways, it was a fun event. Not the best place to do astronomy. The light pollution was pretty ridiculous. But some stars and double stars and Saturn were very, very good that night. And I wanted to say thank you to Krystal and to the Meenakshi Sundar family for helping at our booth and our table. Speaking of Krystal, I'll have another slide coming up and I'll let her talk to it, but she's got her daytime solar science thing coming up. We also have a members star party coming up on the 18th. We have member mentorship night scheduled for the 25th of October. We did this earlier this year and it turned out to be kind of a success. So we're going to try again. And the idea behind this is we will have several of the more well-seasoned HAL members out and without their gear, but with the sole intent to just help new members if they have any questions or want to have some problems with gears or have general questions. And then we have a public star party coming up on the 1st of November. I'm CTA, the telescope operator for that. Chris Miskowitz and Ernie Morse are the hosts. And I'm hoping for good weather. I've got I know there's at least one Girl Scout troop coming, and hopefully we'll have another good showing like we did on the 4th, 5 days ago. So this was the parking lot at Alpha Ridge. I counted like something like 60 cars in this picture. And when I went to, I kind of walked around to the around the back of the park to the seating bench on the hockey arena to get this picture. And I had to wait 5 minutes to get a picture that didn't have headlights drowning out the picture. There were people coming and going. So there's 60 something cars, but there was just a lot of in and out, and this is a snapshot. So I think we had over 300 people. That's a guess, but that's my guess. And I walked around and saw around 20 telescopes set up, including the big one in the observatory. And Krystal had her activities tent, and lots of kids were making experimental landers on their little moon surface that was over here. You can see, can you guys see my mouse online?
Yes.
Yeah, so there's like a little lunar surface, and the kids were trying to make ping pong balls land, or you can talk about it. But this is the first star party I've ever seen where people actually spilled over. There was a telescope on the back in the grassy area behind the telescope. So, we had a lot of people that night. Anyways, the weather was nice, and I hope we have another good experience like that in November. Another thing that's coming up is HAL is going to be featured on the show Outdoors Maryland on Maryland Public Television. So you may recall this summer that they came to one of our star parties and filmed just what was going on. They also went out to the Blackwater Wildlife Refuge. There's an astronomy program there. And I'm not sure how this all came to be, but they came out, they got wind of the fact that I like to go out to Western Maryland with my telescope to dark skies. So they came out with me and did some filming of me out there doing my thing. So I think it's about an 8 or a 9 minute segment. I haven't seen it. I don't know what the focus is. I think they're going to be talking about dark skies, because they're talking about getting away from the light. They were asking me questions like that. So anyways, I'm excited. So this will be good exposure for HAL, and
Can we offer a recommendation?
Sure.
Is talk about light pollution and the easy capacity to adjust policies that require some better governance of the conversion sequence of the sodium vapor to LED lighting to put side shields. It's very inexpensive if it's done up front. And right now, the enforcement of these types of policies is de minimis. So we have an awful lot of light pollution that is totally avoidable. You can see what communities who do support that type of policy legislation, how they've improved their nighttime skies. So
I think you need to get involved. You seem to know a lot about this. There is a relatively new chapter formed of the International Dark Sky Association. There's a Maryland chapter formed, and we have a meeting on the 16th next week, the Thursday.
give me the time and place.
Yeah, let's call it Dark Sky International. It's not ID anymore.
Yeah, Dark Sky International. Thank you, Joel.
Rebranding.
There's a Maryland chapter, and I'll tell you what, I have it in my email inbox. Maybe I'll just we'll post it on the HAL website. I'm not sure whether we can post the link to their meeting, but let's talk offline.
Yeah,
I can give you some
But the
contact.
point is to get some action and traction in terms of the policies and governance structures at the county level, and maybe even at the state level.
Well, we have
I've
people.
been testifying. I was testifying for about 10 years. on behalf, I couldn't be on behalf of HAL because we can't be an advocate.
I see.
But I was chair of Rec and Parks Board for a year, and these people know I was at county
Got
council
it.
meetings. And with, depending on the administration, there was a test pilot program.
Yeah.
New administration came in, they pulled down all those lights it was down in Ellicott City, where they were doing all the testing and being able to do things.
Yeah.
Recreation and Parks actually has been at the forefront nationally
Okay,
as far as its conversion
supportive.
to LED downlighting and how people over the years testifying at on Rec and Parks about smart lighting. So we've been involved over our 20-year history.
Okay.
But if you're an advocate and want to get
Please,
involved,
I'm gone now, so let's go to the
Yeah,
county
let's,
council.
Well,
let's
I
talk
just-
offline.
It's,
Well, there should be some time at the end of the meeting to socialize. We can talk
Okay,
more on this.
thank you. Sorry for the interruption.
No, that's
good.
fantastic. That's good. We want as many advocates as we can for this. I do. Anyways, that's coming up and you can live stream it. The other thing that's coming up is our December, it's kind of early to advertise this, but I don't know, I'm excited about it because we're gonna have it, catered this year. Not catered with with a formal, red carpet or anything. But in years past, we've done potlucks, and this year we'll have maybe Mission Barbecue or some other vendor, bring in food. It'll be here at the Robinson Nature Center. It won't be on the date that we would normally hold our meetings. It's going to be on Friday, the 5th. And we won't have a full meeting. Maybe I'll have a slideshow going with some of the pictures from events over the year. And we'll just socialize, have some food. Maybe if we've done this in the past with an Astro swap. And also on that Friday night, Joel, maybe I couldn't find the
There are two
information.
shows. There's a family show where a lot of young children from 6:30 to 7:30. And there is an adult-only show from 8 to 9. So that ties into this, and I can talk more also about the planetarium.
Yeah, so maybe at the next meeting, we can go into more detail, but there will be, yeah, so you can, socialize the meeting, go catch the planetarium show, come back down, whatever. So stay tuned. So next is Krystal. I think you're tired of seeing this, of briefing this slide.
No, it's fine. I'm excited for it. So yes, this is the final reminder. We're getting close to the event here. So not this upcoming Saturday, but next Saturday, October 18th, we are having a solar science and engineering celebration from noon to 4 p.m. So this event is really just public outreach to have people interested in viewing the sun safely, a little bit of like solar safety education as well. But I'll have also 15 to 17 tables of hands-on engineering challenges, demonstrations, some NASA science, some missions that are interesting. The event is free and open to all, so everyone is welcome. And the goal here is just to really encourage and get people excited for STEM in our community. So if you have questions or if you're interested in volunteering, just email me. But the QR code here leads to the calendar event on my school's webpage. There's a taco truck, so there'll be a taco truck and some games and just a really nice outdoor festival for families to come out and enjoy the sun if weather cooperates. And Howard Astronomical League, we got a couple of people that will be volunteering, so we'll have a meteorite table by Joel. Bob, and Arjun's typical solar system scale table will be there, and a couple volunteers who will have their solar telescopes out as well.
Great. So we'll move right into your next slide too, since that's the next thing on the agenda.
Yes, so I actually, as I finished this book, I changed my mind on it being beginner friendly more to intermediate. So this is a fantastic book. It's called First Light: Switching on Stars at the Dawn of Time by astrophysicist Dr. Emma Chapman, and it's about a medium read, close to 300 pages, and the version I have was published in 2022. So what I loved about this book is that it focuses on something called Population 3 Stars, which essentially is really, as the title kind of hints towards, is what were the very first stars like? We have, as astronomers and the astrophysics community has done a lot to learn more about our universe's history. When trying to build up the timeline of how did we get to where we are now, there's lots of different topics that are really fascinating. You get into, can you talk about direct core collapse black holes? Can you talk about, what were the first stars like? Can we find evidence or ever directly observe one? And I really enjoyed the book, and I move it slightly to the intermediate level just because there are some concepts where I feel like you would appreciate them more with, a little more background, and just general astronomy. Maybe not something you hand off to a middle schooler or a high schooler, but certainly someone who's been in the hobby for a year or two could jump into this. I will say the structure of the book is like that friend who is overly enthusiastic. Like, hey, I'm so excited to tell you about this, but before I can, I got to tell you something else and something else. And actually, while I'm on this topic, let me tell you about something else. So you're on for a journey as far as like hopping around several different topics, several different interesting little niches of how this story has evolved. I will say, it's not the book you read if you're like, I just want facts about Pop 3 stars, because this is a very new field. There is not actually a lot of evidence or understanding of this generation of the first stars. So this is not the book where you're like, this is not a textbook. This is not going to give you factual reference material. This is here's the current status of what we're trying to learn. And so I think it really does a great job of, encouraging that interest in the topic as a whole. So yeah, that is First Light by Dr. Emma Chapman.
Thank you. That's a really nice review. I appreciate it. I'm downloading the ebook right now.
Great.
Okay, so thanks. We'll get back to our, I can get my mouse to go where I want it. Okay, so we're at the point where we're ready for our featured speaker, Guy Brandenburg. He is the president of National Capital Astronomers. He's a retired DC public school math teacher. He made his first telescope in '91 under the guidance of Jerry Schnall. And in a class in DC that he runs today, I think you have you like to stay put because now you're you were teaching at the college, at the school you went to school at as well. So he went to Dartmouth and got a BA in '71, secondary math education in '81. That's what Krystal does too. She's a math teacher.
Oh,
And his ninth grade, we had another ninth grade telescope maker. It's all sorts of coincidences tonight. We're gonna play the lotto. Anyways, he DCPS, I guess that's the school.
DC Public School,
DC
junior high school.
I see. Okay. So that's where he actually retired after 45 years later after teaching. And currently he's the president of National Capital Astronomers. Comes highly recommended by Chris Todd, who's a former president of HAL. And so he's brought all sorts of goodies, and I'm very excited to hear his presentation. So with that, take it away.
hi, what lights would you like on?
I think this is fine so far. Let's see, how do I start my presentation?
So I will stop sharing,
Okay,
and then if you can find your Zoom window
okay,
and find the green share thing in the middle.
okay, so I don't, okay, let me try that again, that's the. So I go to Zoom. And then, okay, I click on okay here.
So you click on that, share,
That share,
Yeah.
okay,
and then you can click your application. Yeah, there you go.
okay.
Okay, and then I will.
Doesn't look right.
Yeah, it started. It's thinking. It's taking a second. There it goes. And so I just need to move that over here. So can the folks online see, oh, I think you're sharing the other,
Yeah, that's
Yeah.
not what I want. Let's start from the beginning, perhaps.
okay, so I think you might be sharing something that you don't want to share.
Okay, stop sharing. Let me share something.
Share, and then instead of sharing the applications, share the entire screen. Yeah, try that.
Okay. Let me try to do that from the beginning.
Yeah, you can, there we go.
Okay, can anybody see that?
That looks good.
Looks great online.
All right, so back in the 9th grade, when I had my astronomy class at Deal Junior High School, my best friend lived across the street from the building where we do the telescope making now. I had no clue that it was there. And at Dartmouth College, I was only really a half-hour drive from Springfield, Vermont. And anybody know anything about Springfield, Vermont?
Still
No? Okay, well, that's where telescope making began in this country. And I'll talk about that in a bit.
Can you guys hear well online?
Yeah, pretty well.
Pretty well. He's a little faint, but it's doable.
You
Okay.
maybe want to come a little closer, Guy, would that be okay?
Closer to what?
The microphone is
No,
here.
the microphone's there. All right. Is this any better?
Yep.
Okay, so the guy on the right with the ponytail, that's John Dobson, who really did revolutionize amateur astronomy, and I'm the one playing with this. I guess I should use the mouse. Wait a second, I don't have a mouse.
Yeah, you do.
Yeah, so right there, I'm doing a pitch lap, which is something you have to do when you're getting ready to polish a lap. And Dobson
Sorry,
is.
you're gonna have to speak up to us.
Dobson was kind of a curious fellow. He said I was doing it all wrong, but that's okay. All right, so now my position is that our ancestors have been looking up at the night sky since, you know, we became a species. And many of them built structures that are aligned with what they saw. And they were the ones that have survived, like Chaco Canyon in the middle, Stonehenge on the left, and the pyramids on the right, just for a few examples. They're amazing. And I'm pretty sure that just about every single human society did stuff like that because, you know, there's no TV, you know. And moving forward in time and going through, you know, some of the important stuff, Euclid wrote a book in 120 BC, and I'm sure you all took geometry and you all studied theorems basically taken from Euclid, like this stuff over here on the right. That's from his geometry book, but the one on the left is his optics book, and basically nobody uses that anymore, but everybody still uses his geometry. Then later, about 960 AD, a guy by the name of Ibn Sal, I'm sure I'm saying that wrong, he wrote an incredibly advanced geometrical study of optics. Unfortunately, it was mostly ignored, and it was only recently that somebody found a couple of copies here and there, still in Arabic, in various libraries, and translated it and reprinted it. And by 1352, you notice that's quite a bit of time in between this 960 to 1300 roughly, is when people started actually wearing eyeglasses. How many of you wear eyeglasses? How many of you have a member of your family who never wears eyeglasses? I see 2 people, 3, 4. Okay, yeah, think about that. You know, we have all become nearsighted. So the first reflecting telescope, that was, you know, a couple hundred years later. Actually, so I'm skipping over Galileo here. And I was wondering how good of or bad of a telescope that was. Now, over on the left, you see a graph, right? The graph is measurements of the what the telescope mirror should be. It should be in between the red lines. As you can see, it's not. The blue line is his telescope, so the optics were pretty terrible. 1.4 lambda instead of 1/4 lambda. And Descartes, if you've ever done graphing equations on a graph, you can thank Mr. Descartes for that. And here's one of his diagrams for, looks like the eye. And he did a lot of amazing stuff that we still use today. And a bit later, we have the very first surviving Gregorian telescope, and that one's got 2 sets of mirrors inside. Now here's a little spreadsheet I made with all the various important things, and I'm not going to go through all of these things. So yeah, so okay, we've talked about most of that stuff. And then there's all these different people who do all these different things, figuring out things. For example, we just saw a Gregorian telescope, but Gregory actually didn't make one, he just described one. Kepler described but did not make a variant of Galileoscope, which was a much better one. I have one of the Galileoscope, and I'll pass that around later. Not that he made it, but it's his design, and it's really a pretty terrible telescope. And then Newton's telescope that we just looked at, that thing was tiny. It was only 2 inches across and only 6 inches long. So that makes F3. And F3 without being parabolized is really not going to work. And Cassegrain again proposes, doesn't really build one of those Cassegrain scopes. And Hooke, that you've probably heard of, did the stuff with the springs and a whole bunch of other things. He builds the first really useful Gregorian at end of the 1600s. And then we have Hadley. He does the first parabolized reflecting telescope. And then Hadley builds the first Gregorian, sort of a conflict between those 2 claims, obviously. Then we have the first achromatic lenses, and that's important because otherwise you get all this rainbow. We've all seen light go through a piece of glass and send rainbows across the room, and you don't want that in your telescope. And HAL and Rolan figured out how to fix that problem by having 2 different pieces of glass, which makes it harder to make because you don't have one surface to get right, like in a Newtonian. You've got 4 that you have to get right. You got to get the first piece of glass, the front surface, the back surface of that one, and the second piece of glass has to be a different composition of different stuff put into the glass, so it has a different index of refraction and different index of dispersion, and you got all 4 of those surfaces have to be very, very good, not quite as good as if it's parabolic, but it's much, much harder, and I can tell you how hard it is. So then we've heard of, how many of you have tried the Messier Marathon? Did you do it? Were you successful?
No, I did.
Okay, well, I've never
I got all
tried.
but 1 or 2, I think.
Well, very good. In one night, that's amazing. We've all done Messier, looks at Messier. And of course, that's a list of things not to look at because he discovered 13 comets and nobody remembers them anymore. But his list of 74 and later 110 objects that are not comets is still used by amateur astronomers today. Then we have the Kellner eyepiece and the Ramsden eyepiece, sort of a gap here of almost 60 years between Ramsden and Kellner. And then in the middle of the 1800s, Foucault and Steinheil show how to make extremely accurate parabolic silver glass mirrors. And Foucault's methods have been used ever since then. And apparently I was the first person to translate his 1859 article into French. Sorry, into English, my bad. People have been talking about it. Then we've got the Plassel eyepiece, and then we've got Abbe has got an apochromatic lens, which is better than what they had. Because it's got 3 pieces of glass and it brings 3 colors to a focus. A lot of your refractors today are that type. In 1920, Porter began making the first amateur telescope making classes in the Americas. That was in Springfield, Vermont, at the J&L factory there. And since that time, they had, the first Stellafane convention. Anybody here been to Stellafane? Okay, that's where it all began, at least in this country. That's the beginning of it. And I went to college near there and had no idea. And around that time, Ingalls, who was the editor of Scientific American, and how many people have had subscriptions to Scientific American in the past, or maybe now?
In the past.
How many of you remember those telescope making columns? Few of you? Okay. So that began in 1928. I tried a bunch of those projects in Amateur Scientist book. Did you know that you could, on that thing, you could make your own accelerator for atomic particles? You could make a Van der Graaf generator for tens of thousands of volts.
CO2 laser.
Don't think they had that. They had another laser that you could.
It was in Scientific America.
Yeah, I'm talking about the book that I had in 61.
Oh, okay.
And you could make an X-ray machine, your own X-ray machine. You used a spark coil from an old Ford automobile.
Cool.
I'm not kidding. Okay, so then in 1932, Strong figured out how to aluminize mirrors, and aluminum coating lasts much longer than bare silver coating, but you have to have a vacuum chamber, which at that point very few amateurs did. We got one, basically government surplus. American University got it, and then they decided they didn't want it. They gave it to us. So NCA was formed in 1937, and the very next year, somebody by the name of Nagy started making telescope making classes, and that still continues. And in 1941, Sky and Telescope magazine was founded. In 1957, Sputnik happened. How many of you are old enough to remember Sputnik? How many of you saw it? Okay, just a few of us, but that made a huge impression. And then a little while later than that, Dobson starts making his first reflecting telescopes, and of course he's a monk in a not a Buddhist monastery, not a Catholic, but a Hindu monastery.
No way.
And he gets thrown out of the monastery because he's spending too much time making telescopes and showing people how to do that. And so he starts setting up these big telescopes, 12, 14, 24 inches, which nobody had back then. We'll look at the cost of telescopes back then. And right after that, humans land on the moon. Now, I didn't know anything about this. I had never heard anything about it, but we all heard about the landing on the moon. How many of you watched it? Okay, all right, so me too. And then not long after that, in the fall, Riverside Telescope Maker Conference begins on the West Coast. I never visited that one. And then in 1970, Tom Johnson of Celestron introduces a C.H. Schmidt Cassegrain, and that's the most popular scope that's ever been sold. It's pretty easy to manufacture. The tricky part is the corrector plate in the front, and they figured out a way of making that very, very nicely without needing really much hands-on stuff. But they did have good quality control, and they still do. It's almost impossible to make one of those at home. Not long after that, a guy by the name of Wall invents a Crayford focuser, and he decided, he'll let anybody make it. He could have patented it, and he decided not to. Not long after that, we've got All About Telescopes published by Edmund Scientific and very useful. And then somebody invented a easy to make interferometer, which doesn't cost very much. And then after that, Astronomy Magazine was founded. And then shortly after that, Hopewell Observatory started construction. And then we have the CCD camera being invented. And the Amateur Telescope Making magazine is founded in '78. And obviously that's cut off. I don't know what was on there. So a lot of things start happening. And you guys got founded in 1999, right? And it sounded to me like from your history that you were sort of an offshoot of a Baltimore group that were given a 12-inch Newtonian and wanted to make a observatory for it. Is that basically correct?
Correct. A hand-built scope from Baltimore in the 1930s to view variable stars. It's out at our observatory now. It's not on the pier anymore now. It's on a fixed pier to the side and not used with our newer scope on the pier now.
Right, so it's a pretty long 12-inch.
Yes, looks like a battleship cannon.
Yeah, okay. And those long ones were relatively easier to make, but harder to use for sure. And so 2015, your observatory opened up? Is that correct?
Correct.
Yes.
Okay. And then just not long after that, a guy by the name of Howard Dutton invented and releases for free something called OnStep. It's completely DIY. It's computerized electronic motor control of a telescope based on Arduino. So what that means is if you've got an old Celestron or Meade or whatever telescope that's got electronic stuff and the electronics die, good luck trying to get parts for that. You pretty much can't. So what you can do is you can incorporate this, and I'll show you some of the stuff later on. But if you're willing to wade into a little bit of soldering and machining electronics, you could have a telescope that works again. So in 2019, the Riverside Telescope Makers Conference ended after 50 years. And there are many fewer telescope makers these days compared to 50 or 60 years ago. All right, so now, question, why did so many people want to make their own telescopes back in the 60s? Well, for example, this is sort of their top of the line 4-inch achromatic unitron refractor, cost $785, $800. And I looked it up, and that's equivalent to $8,000 today. And a single eyepiece costs the equivalent of $400 today. So I never had a telescope when I was a kid. And a Questar, a 3-inch Questar was set, again, the same thing. And that was 1954, different dates. So that's $9 grand. And there's the Cave Astrolas. Those are very nice telescopes, at least at one point. And okay, go. So it's a lot of money back then. So if you, and even a kind of a crappy little all plastic tube, that's about $450 in today's prices. And yeah, it goes on. So now this was kind of a big thing. The Odyssey made by Cultural Optical, and I forget the year of this, but I had it on the other page. But that would be about $1,440. Very crude telescopes, and sometimes the optics weren't very good, but you could improve everything, and a lot of people did do that. Okay. Come on. Oh, wrong button. Okay. And actually, I would have to say that commercial telescopes that you can buy are way cheaper, way better than they used to be. So you don't have to make your own telescope because you can't afford another one. All right, so I began looking through the NCA, that's National Capital Astronomers Archives, and this is from 1960, and they're talking about the very first, say, decade or two of telescope making. And for 7 years, a woman was in charge of the telescope making class. And they ended up having multiple classes in Bladensburg, Maryland, and Fairfax, and a bunch of different places all over the DC area. And they were big on wooden frames and all sorts of things that were made pretty inexpensively. And I was rather appalled to find out that when they're making this constitution, that they were going to say, now only Caucasians over 16 years old are eligible for membership, and they want to make it so they'll include all the ages and exclude only the Black race. So this is back some time ago. So somewhere in between there, that stuff was put in there. We don't know who did that, but our current leadership is aghast and has repudiated that language. One of the ironies that George Carruthers, anybody heard of Carruthers? No, just me. Okay, he spoke to NCA in January 1970, right after this change, and he could not have been admitted as a member when he was a 10-year-old kid in Chicago, I think, when he was building his own telescopes. And he is actually going to be the subject of our talk at actually day after tomorrow, starting at 7:30. David Dvorkin will be talking about George Carruthers and his work. So here are some of the places that NCA has held its ATM classes. Our current home is at the Chevy Chase Community Center in DC. And I must say, without the help of the DC Parks and Recreation Center and the organization as a whole, who give us this room for free and keep all our stuff in there for free, we could not exist. So here's my predecessor, Jerry Schnall, and that funny looking object there, that is our vacuum chamber, and we can do mirrors up to 12 inches, 12 and a half inches in there. So this is an observatory that was, question. Okay, so this is an observatory that was built by mostly NCA members, and the people who built it were amateur telescope makers themselves. And here they are at work. So they did all the work themselves, and that is a humongous mirror that we end up eventually selling because we couldn't deal with it. Here they are at work.
Where is that observatory?
That is, if you know where I-66 is?
Yeah.
Out of DC, go straight west on I-66. You get to Haymarket and you see a ridge in the distance. If you look really carefully, you can see a FAA radio radar dome, and you can see a cell phone tower. So we're on that ridge near US 15. And that is the Wright Newtonian telescope made by one of our members who is now deceased. So that's this one here, the Wright Newtonian, and it's got a corrector plate very much like a Schmidt, but it's not a Schmidt. And this is a Maksutov that he also made. And here's one of his pictures of, I think, Halley's Comet. And this is with film with those telescopes. And that was done with that telescope that you just saw. And here's some pictures from 1977. This is the type of measuring device that was used up until pretty recently. We don't use that particular method anymore. There's a whole bunch of ways of measuring telescope mirrors. And one of the neat things about them is that we're able to get the accurate to within a tenth of wavelength of light over the entire surface of an 8 or a 12 or whatever 18, 16-inch mirror, which is pretty freaking good. So this is the type of telescope that people used to make back in the 60s. This is a 10-inch f9, and this is probably plumbing parts for a steamship or something like that. And I put it on a Dobsonian mount, and that sucker is still heavy and really hard to use. We sold it to somebody else. All right, so here's some more recent telescopes made by various people of various different ages. The one on the left, that's out at HAL, that's in California. They have one of the few still regularly meeting telescope making workshops every week at the Chabot Science Center in Oakland. And here's some kids making small telescopes and various other optical things. And that's a pretty nice one. It was made in our workshop. Another one. And this is the telescope that you see over there, taken out to Wyoming for the eclipse back in 2017. And we have to keep dust and grit from getting on the mirrors. We put the mirror polishing part under a tent awning like that to keep the dust off, and it has made a huge improvement in lack of scratches. And there's always problems to be solved when you're doing this stuff. And again, various different things, people making stuff. Now, there's also other things that you can make pretty easily. This device right here looks like a sundial, but it's not. It's a clinometer. There's a little straw there, and you aim the straw at the sun. Hopefully you don't look through the straw. You let the light come through it, and then you can figure out what angle the sun is at. So this is just a clinometer, kind of like a theodolite. I did this on the solstice, June 21st one year. These are future math teachers. And since it's a solstice, the sun was as far north as you can get. So all I have to do is find the distance to the Tropic of Cancer, which is just below Miami. So just find the distance from Miami to, or I guess I should say Key West to DC, and multiply that by whatever angle you get, and you've got the size of the Earth pretty accurately. Done that with my students many years, but we're not in school on the 21st, so we do it on the equinox. After I've had almost a year to teach them how to do stuff like that. And here's some more telescopes that people make. So this young lady was pretty young when she made it. She's a lot older now. And this is an activity where I had some surplus lenses, and I got some PVC and some really inexpensive eyepieces, and it all comes together looking like that. The main activity that the people did is painting the tubes and putting all the parts together. And it makes a pretty neat little telescope. And the one on the left is one that I made during the COVID epidemic, when I couldn't get out and do anything. And I was hoping I could do it all by myself, but not quite. So the round thing there came from a drum. What do they call that? The round part of a drum? Not the skin, but whatever that is called. And this was made by a professor at Georgetown University. He calls it the Riccioli after a fairly famous astronomer from Italy. This is my 12.5 there. And you'll see some more pictures of it. We also have a machine that we've used and modified and so on. So it's useful for big telescope mirrors. I've got a 16.5, and I did that mostly by myself, and I really seriously injured my back very, very badly. And it took quite a bit of time to recover.
By
Having
lifting
a
it?
mirror like that on a machine that goes around, and then you can move the thing, the polishing thing by hand or with a machine, can certainly save a lot of aggravation.
Kyle, you had a question?
Yes,
You hurt your back by lifting it up? It's-
not by lifting, but by
Oh,
pushing the thing
up.
back and forth for hours at a time and not stopping when it hurt.
Oh.
If I had stopped when it hurt, I think I would have been fine, but going past the danger signals that my body was sending me was not a wise thing to do. It's also a little bit heavy too, but not that bad. And this is just a data sheet that we use, hand-drawn data sheet of the measurements that we take. And I was telling you about Chabot Space and Science Center out in Oakland. Every Friday, I'm going out there at the end of the month to visit my daughter who lives out there and her family. And they've got a nice setup there in a center much like this, but this center has a whole bunch of big telescopes in it. And that is their measuring device. They use something called the wire test. And this is some pictures from Chabot. And I've also gone to other telescope making workshops. I've gone to the one in Delmarva. They used to rent a hunting lodge and take it over and set up a whole bunch of stands. This, I believe, is Steve Swayze, who recently passed away, was a major telescope maker. They paid for him to come out and give lessons. And that is his method. I think that's the Ross null test. It's pretty neat. I've not used that one myself. This is a really good test, except you really need to have the mirror here that you're testing. That has to be parabolized. What you have here is a flat mirror, really, really flat, optically flat. And you've got a little hole in the middle, and you've got a little light source and a grating or a knife edge. And the light comes out from here and hits your mirror. If your mirror is truly parabolic, then all the light is going to come reflecting back, not to your focal point, but just parallel. It's the same thing that your lenses, your reflectors in your car lights are. There's a parabola back there, and they put the little filament right at the focal point, and then all the light comes out this way rather than going all over the place. And so the light comes back, hits this flat mirror, and then goes back to there. And again, if it's perfect, then all the light is going to come back to the same point that it came from. And that is if your mirror is perfect. If it's not perfect, you will see the deviations. And then you can interpret those deviations and decide what to do. But setting this up takes a long time. This is sort of a panorama view of our mirror making workshop a few years ago. This is a telescope that was made there. And yeah, this is not made in that workshop. This is somebody who made it completely on his own. And this was made in our workshop. This is a nice Crayford focuser. How many of you know what a Crayford focuser is? Okay. it's a nice focuser because there's no backlash. So he made that with the lathes and milling machines that we have in our workshop. And here's something he's showing me that is something called on-step. Anybody here heard of on-step? Okay, one person. Okay, so what it does is it's a control system using very inexpensive printed circuits and components like resistors and capacitors and transistors that you could buy off the set, and also a number of integrated circuits that you can that have been specially made for this. And it does all the controlling. It can, you know, if you've got a observatory roof, it can control that. It can, you know, lots and lots of things. You know, focuser, pointer, and so on. It's pretty amazing, and it's all free. The software is free. You got to pay for the components, but they're really cheap because today lots and lots of people are doing 3D printing. How many of you own a 3D printer? Okay, how many of you know somebody who has a 3D printer? Okay, and those 3D printers all use you know, basically the same circuitry and the same types of machines. And here's his thing, you know, working. Now, most of the time, most of us make parabolic mirrors because it's so simple. You only have to get one surface correct. Now, one fellow, his name escaped me, the focuser is made of aluminum. Everything was aluminum, just pieces that he found. Okay, so and this is an ellipse, as you can probably tell. So the Dahl-Kirkham telescope has an ellipsoid here, and it's almost impossible to tell by naked eye the difference between a sphere and a prolate ellipsoid or a paraboloid or hyperboloid, but we can tell. And we tested that with some pretty neat stuff. I was quite pleased with this. I took a swizzle stick, a glass swizzle stick, and heated it up and drew out a fiber of glass, and then broke off the end and got a little tiny ball of light, and that was attached to this thing here. And I put that at one of the focal points that you saw in that. So the light, I think, went right here, and we were testing it right here at the second focal point. And once we got a nice null, we knew that telescope worked fine, and it really did work fine. It's a nice short telescope. Now, it had to have a bunch of little lenses to correct the Dahl-Kirkham, and that's not so easy. That's way above my pay grade, but he did a very nice job on it. And not all of the telescope projects work. This is something called a Lurie-Houghton, and a Lurie-Houghton has two corrector plates, but they're the same type of glass, and surface number 1 can be ground against surface number 3 and surface number 2 against surface number 4, which made it easier, but it still failed, and we don't know why. It's nice green color, but it doesn't work. And this is kind of a neat little thing that somebody brought in. It's I think a scanning tunneling micrograph, so it's able to tell the profile of the glass at 120 grit. And 120 grit, by the way, is pretty coarse stuff. And another interesting idea somebody had, I think this is John Avalone who decided on doing that. It was based on an article in Sky and Telescope. The idea is you glue a mirror to a cell, and I think the cell is made from a automobile tire, and then you pull on it, And this was a spherical mirror. Was this the same one? I don't know. This one is 16 inches across. That does not look like 16 inches to me. But if you pull on the mirror, it becomes closer to a paraboloid. So it did work. And here's Stellafane, and lots of people bring up telescopes that look like this or look like that. Some of them are just incredible workmanship. Some like mine are not so much incredible workmanship. And here's some directions I gave for using various pieces of PVC to make a pretty decent refractor using an achromatic doublet that I got from Surplus Shed. And here's another homemade telescope. Now this one was a black vitrified ceramic that was brought in by this fellow, whose name I've forgotten. And black vitrified ceramic, or VVC, was something that has a very, very low thermal coefficient of expansion. It's layers of glass and then some ceramic and then glass and ceramic. And it is soft, not made any longer, but apparently did a really nice job. Oh, I don't know why I did that one again.
All the toys.
And
No, it's been.
oh, so this over here, let me show you, talk about this here. This is an interesting pitch lab.
Yeah.
That's useful if you have a very, very much aspherical, not a sphere, something that deviates a lot from a sphere. Sphere is easy to make. Parabola is much harder, and this thing here with the facets larger in the middle and less so on the outside has the property of mostly working on the inside, which paradoxically helps to parabolize the mirror. Okay, another thing that's happened recently is silvering mirrors. Now, that's what Foucault did back in the 1850s. But and I was thinking this couldn't possibly work, but darn if it didn't. I just made a little, frame here, went to Stellafane and saw some people do it. But actually, somebody gave us a kit, and this is after silvering, and the silvering has been on that mirror for a couple of years now, and it still looks pretty good.
Oh.
And I mean, it's sort of, I didn't believe it at all that somebody could just clean the mirror, sensitize it, put on a layer of stannous fluoride, and then you have two things that you squirt with your hand. One of them is basically ammonia as a reducer, and the other one's got silver nitrate and stuff. And you spray it on it, and all of a sudden you got this beautiful shiny mirror.
Wow.
And then you wash it off, and then you put on this other stuff. I have no idea what it is, that protect it, and you just, rinse it off, and it's done. And I could not believe that it was not going to mess up the figure, but it doesn't.
Oh.
Astonishing. The kits are not cheap though. Silver is obviously not cheap. Yeah, so that is, I think I just took that a little while ago. So it's still in, not perfect shape, but not bad. Yeah, I was talking about OnStep earlier. And this is the kind of stuff you can see up at Stellafane. This one here was amazing. To collimate this telescope, all he does is rotate these struts. The strut is, got, one end has correct thread, the other one has wrong thread. So it raises and lowers it a little bit. And this is a secondary with a battery holder in it. And that keeps the dew off. And this, the workmanship on that and that is just amazing. I'm very impressed with those people. But most of the people who go to Stellafane do not bring their own telescopes. They bring Schmidt Cassegrains and refractors and stuff. And this is an explanation from Wikipedia about why Newtonians are the most common telescope made. Is because it's the easiest one and it does a really, really good job. And since we're talking about costs, I did a few possible things. So this is a do-it-yourself kit from our workshop. The glass, this is all for an 8-inch Dobsonian. This would be plate glass. Luminization is $35. You're going to spend about 40 hours pushing glass. The focuser, we've got a bunch of old focusers. You're going to have one for free. We got old finders. You're going to have one for free. The secondary mirror you're going to have to buy because we're out of them. They're getting pretty expensive. And the spider, you can make a spider, but it's a real pain in the butt. I would go ahead and buy one. And, you know, you can scrounge up a whole bunch of, we've got lots of paint. We've got lots of screws and other materials. And I'm going to say you're going to spend about 30 hours on construction. And you can certainly brag about what you've done by the end of the time. So the total of 70 hours of labor, your labor cost, I don't know, depends what you want to give to it. So your total outlay is, you know, not much. Now you can buy higher quality stuff and spend quite a bit more. And let's see. Oh, we've also got cases where we've got mirrors already done. So that might be quite a bit cheaper. Now, I looked up used ones. They're expensive used ones and they're inexpensive used ones. Now, if you get a inexpensive used ones, you might not have to work on it, but then again, you might have to. You might have to fix things. But you know, anywhere from $275 to $700, depending on, you know, high end, low end refract. And these are the prices for commercial ones. This one is for Apertura. This is from Celestron. This is from Skywatcher. This is also Skywatcher. So that one's the most expensive of all of those. And this is some other calculations I did earlier when Orion was still in business. Unfortunately, they are gone, and so is Meade. So your cheapest bet is to get yourself a used Dobsonian and then learn how to fix it. Definitely. Okay, another thing. Okay, this is, let's see, is this the little video? Yeah, okay. So that's my hand in front of a telescope that we're testing on our current setup. Notice the, did you notice that?
Mhm.
That is an incredibly accurate and sensitive test. And all it is just a little slide of plastic that has these lines etched on it, 100 lines per inch. So half of it is dark and half of it is transparent. And you put your eye or your camera right next to an LED that's putting out light that bounces off the mirror that you're looking at, and it comes back to you. The nice thing about this is you do not have to have the mirror already illuminized. And another, oh, we've got a Maximat
Nice.
metal lathe from God knows when. Works quite well. And we've also got one from South Bend.
Telescope.
That was made in World War II. It has a sign on it saying conforms to the orders of the War Production Board. Unfortunately, since it's been used a lot, so essentially it's 80 years old, the tolerances aren't very good on that one. You sneak up on something and then boom, goes past there. but it's still a nice one. We've got, oh, this is that machine. We've got lots of books in our library. And let's see what else. We've got lots of nuts and bolts, and that's our luminizer again. And in case you're curious, the one on the left, that's a mechanical pump that will probably last for another 50 years or so. And this here is our power supply from melting the aluminum inside the chamber when we get the vacuum down low enough. And then there's another pump underneath the device that I don't think I'm showing you. So there are a couple of, I was talking about on-step. This is a better image of what the little board looks like. And they've put some things on there to dissipate the heat. And so this little scope here is on an equatorial mount, and it's got one of these on-step controllers on it. And then the mount itself is in part 3D printed, which is kind of interesting development. At the Hopewell Observatory, we had this beautiful big telescope with a clock drive in it that was made in, I guess, the late 60s, not long after Sputnik, when every university was buying telescopes. And this, as you can see, a lot of gears and stuff, and it had clutches in there. And the clutches died, and the guy who knew about all that stuff passed away. And so either we had a very, very heavy counterweight on our hands, or we could spend many thousands of dollars buying a system from a guy out in California. His name is Dan Gray. Or we could do on-step, and we decided to do on-step, and that took a lot of work taking everything apart. This telescope had really beautiful gears by Byers. That's the big spur gear, and this is a worm gear. And then there's another gear here. The motors are back there. You can't see them. They turn this worm gear, which turns this screw, the spur gear, which turns that worm gear, which turns this at a very nice, precise speed. But the thing is, you have to get it to go the right way at the right speed. And these are the old electronics that we basically just tore out. And this is us testing all the stuff on the workbench, trying to get it to work. It was quite a bit of operation. And then finally we had to build or purchase a box and then put all the stuff inside because it could not fit any longer inside. This took almost a year because most of us really did not know what we were doing. We had to get bailed out by the on-step community who gave us, all kinds of advice, and even, maybe even that board there. Yeah, they're extremely helpful. And also Arlen Rash from Virginia was extremely helpful. And this is my latest project. I don't know if you could tell, but that's a 16. I made the mirror on that one. And that is an old Meade light bridge that I took out. Well, somebody else took all the insides out. And this is another 3D printed telescope. It doesn't have to be that long, could be any long. But I think that's a pretty neat idea because all these little parts there, that can really get to be kind of a difficult thing to make. I make them out of plywood because that's what I'm used to, and various pieces of plastic like from tubes for like sewer pipe and stuff like that. But 3D printing can work well if you know how to do that stuff. And another interesting thing that's come is the whole set of things like C-Star that do electronic assisted imaging. Now, if I can do something like this in like half an hour with something like that, I'm not sure I really want to spend my time at the observatory making pretty pictures when I can make pretty pictures without any effort there. Now, doing scientific work, that's a different story. Believe it or not, one of our young fellows, I guess he's in the 9th grade now. He actually used his C-star and he got a good light curve on an exoplanet just this past week. I was quite impressed. Yeah. How many other people have one of those? Okay. They're really impressive. Okay, now another thing you can do if you don't want to make your own telescope and you want to make pretty pictures and you don't have your own observatory, there's something called Starfront Observatory. It's out Arizona, I think someplace. And it holds literally hundreds of high-end rings all under roll-off buildings. And I watched their video and they get 2 or 3 new rigs every day. And they have 500 as of last count. So if you've got a lot of money, like enough for a new car, you could spend it on an observing rig and have all the latest features and send it out to them. You can go out there or just have it shipped to them and they'll set it up for you for a fee and they'll babysit it as much as you need for a fee. And if you need to solve a problem for a fee, they'll help you fix it too. But I think it kind of takes the fun out of it myself. So if you're interested in making something yourself, keep in mind, not all projects get finished. The more complicated the project is, the lower the chances of completion. Nice thing about Dobbs is they're so easy to make. You only have one optical surface to get right, and then build the rest of it, which is pretty simple carpentry. But, stuff like this, you're not going to see with the naked eye. It's all, cheating, really, because they assign different colors to different wavelengths that have nothing to do with the human eye. And the human eye obviously requires quite a bit of light in order to see color, and we can't keep the images in our eye for 2 to 10 hours at a time. We just can't do that. So now, does amateur telescope making have a future? I would say yes, but nothing like in the past. And I'm done. So I think seems to me that the future is for people who are interested in making something highly accurate with their own. That is a really nice thing, because think about it. We're getting accuracy to the level of what microchip makers make. They're getting stuff down to the nanometer, 5 to 10 nanometers, and that's what we get. Actually, let me show you this first picture again on that thing. And let me. So this sort of thing here, I don't know if you can see it. I don't know if I'm doing the right thing. Am I doing the right thing? I just wanted to show this picture here. How would I do that?
Go back to Zoom
Go back to Zoom.
and then click on share.
Share. And then, so,
There you go.
okay, that's what I thought I did. Okay, so, yeah, so this is on a street corner in Washington, D.C. Whoops, I went to the slide. Okay, so let's go back to the very first slide, because that's what I want to look
If you click from the beginning, or
at. Okay, let's try it from the beginning. All right, there we go. So we had people, who were not coming to us to see something. They were just walking by in downtown Washington, not actually downtown, uptown Washington. Columbia Heights, Adams Morgan, Mount Pleasant area. And so that's a 12-inch I made in the middle. And on the left there, that tube above the young lady's head, that was made by one of my students who is unfortunately one of the people who's going to be deported out of the country beginning of the week because he's from Venezuela. Brilliant kid. It's really a shame. But if you're talking about saving money, if you're if you're not wealthy, it is still a good way of making a decent telescope. And you can bring it out to street corners and people will really be amazed by it. But we certainly don't have the numbers of people that we used to back 50 years ago when they had multiple sessions and multiple locations. But I still think it's fun. And at some point, if you have a telescope, you're going to have to fix things. And the more you know about fixing things, the better off you will be, especially if you got a used telescope. And so right now, I call this workshop the Amateur Telescope Making, Modification, and Maintenance Workshop. So people can come in and have us, diagnose their problem. Sometimes we can solve it, sometimes we can't. So that's pretty much all I had to say. Any questions?
Thank you very much.
I have a question about 25 years ago when HAL started and we inherited the Watson scope in pieces that time. And I wasn't involved in this, but our mirror was sent somewhere to Washington to be evaluated. Would that have been sent to you all, or if we wanted to get the
I don't recall that.
but is that something that when
We could
doing
do
that
it, yes.
testing?
We certainly do
So it
do
was
that sort
somewhere.
of thing.
I'll have to go back, like maybe Wayne, or do you happen to have those from way back when?
Joel, I think I remember that Michael Chesness, in fact, took the mirror down to NCA to be tested.
Yeah.
Okay, so
Yeah.
then I did.
Probably that goes back, and somewhere in our archives are the measurements,
Okay,
and that.
and they're not up here, I guarantee that.
Yeah.
Yes,
I just want to point out an interesting evolution in the spider mount technology is that historically has been a 3-point linear mount, but interestingly, some work has been done and I've proven it to be successful is using a curved spring steel to eliminate much of the optical distortion that one gets when looking at a star using a reflector.
yeah, I don't know if you noticed, there was somebody who did that on one of theirs.
So that would be for someone who's starting out to make one, a recommendation to use that innovative step forward. And when they make it, they're actually not all that difficult to make when you consider, if you've gone through the hard stuff and making a reasonably good mirror. I did want to ask while I have the floor is do you have anybody who has been suitably equipped, either intellectually or out of curiosity, to make their own refractor lenses?
I started, I did not finish.
No Clark in you.
I finished one,
Did you?
a few years ago.
You started a refractor?
I finished one, I did most of the optics over the pandemic, and I finished it, 2 years ago, depending on how you're counting finished.
Wow, what was the aperture?
It's a 4.5 inch doublet f/16.
Outstanding.
And I'll attest that it produced outstanding views this weekend at the Star Party.
Fantastic.
It
Wow.
was really
I'm
nice.
very impressed.
Let me get your signature.
What are you looking for, Victor?
We have pictures of the testing of the somewhere in here, we have pictures of the nope, not there. Somewhere online. We've got,
There is Watson scope.
That narrows it down.
Watson scope, middle blue.
well, somewhere there was something that looked like a interference. Here it is.
Oh, so that's,
So this is the Watson scope, some of the, diffraction stuff or whatever. I'm not even sure I understand what these images represent.
those are Ronchograms. And if the lines are straight, that means you've got a sphere. If the lines are curved, that means you have something else. And I don't know who took those images. I don't think it was me at 7:44 a.m. But
There's some roll off on the edge, which is typical.
yeah,
Yeah.
looks like it has a bit of a turned edge, perhaps.
This is the scope. It's sitting on this pier right now in our observatory.
That's not that long at all.
I think it was an F5.
F5.
Yes.
That's awesome.
Okay.
Can you guys see the slides now? Are there any other questions online?
I just wanted to apologize to Guy for not being there in person and to show you what an illuminized 8-inch f4.4 looks like. So I don't know if
That was
that's showing up in the room,
Yep.
but I had an enormously good time grinding that from the end of May through roughly August. And my sales pitch for amateur telescope making is you can be as perfect as you want to be. And you can make a better mirror than one you can buy, because you could be willing to spend as long as it takes to be perfect. And it very much satisfied my OCD. I loved making that mirror.
Can you show it again, please?
Yeah. Is that
Um,
showing up?
Yeah.
Oh, yeah.
Yeah, and we illuminized that using that chamber. It's also a very thin mirror. This was a piece of plate glass that had been slumped. It's only about half an inch thick. And it had been slumped previously. But
what's
if I
slumping?
remember,
Can you explain slumping?
take a flat piece of glass, warm it up, and let it kind of partially melt over a curved surface to get basically a curved piece of glass. And so the backside of this mirror is not flat. The backside is also curved. You won't be able to see it here, but it did make grinding a little bit interesting because we had to build a dental plaster support for the curved back of the mirror. Otherwise, it might have induced some astigmatism during grinding. So
Cool.
It did come out very, very nice.
I'm happy with it. I still haven't been back, Guy. Sorry about that. Got busy. But yeah, I'm gonna start working on building the telescope here pretty soon. So I actually hope to be back at the workshop tomorrow night.
Okay.
Cool.
Guy, I have one more question. If you track the evolution of mounts and drives with your excellent presentation on the optical components, would you see any kind of evolutionary roadmap that was, in similar nature, where you really had truly advancements in the state of art versus just improvement on their previous state of art. And if you put those two together, would we see how being able to guide the telescope as well as the optics really yielded eventually better scientific data?
Oh, yeah, I mean, without a good drive, the telescope can't keep looking at the same thing, and so you can't take scientific data. A hand moved telescope is not going to do that. You can take a photograph of the moon or, some other bright thing through the eyepiece. But yeah, starting, they've been working on mechanical drives for quite some time. And you saw the one from Hopewell. Right now, the latest thing is something called the strain wave, which I don't fully understand, but the idea is that some gears that slightly deform, you have extreme ability to hold much greater payloads, and I don't know about what their error is, and periodic and stuff.
All right,
But all that stuff keeps getting better.
I think we need to move on. But thank you so much, and thank you so much for that excellent presentation. And thanks for all your questions. So, and I hope at the end we might have a little bit of time to just sort of walk around and look at what you brought.
Oh, yeah.
So next we have our shallow sky highlights. Jim?
Alrighty, so Jupiter is still a morning object for you. It's going to be rising shortly after midnight, so it's well placed if you're willing to stay up or if you're willing to get up a little bit before the sun. Right now, I think it's like roughly every 400 or so days. We talked about it last month. You get because these moons are kind of in a locked orbit, you get double shadow transits. So we've got 3 of them for our area that are coming up over the next several weeks. One on October the 11th, which I believe is Saturday morning. So no reason that you can't go out and see that one from 4:45 to 6:50. Another one on the 13th and another one on the 20th. These should be very visible even in a small telescope. Usually you can see those shadows on the planet. Next. Of course, we've got Saturn out there, which was just past opposition a couple weeks ago, about 3 weeks ago. The rings are growing more and more edgewise, even though Saturn had its equinox back in May. Due to the dynamics in Saturn's sky, we are kind of like sinking below their equator. So the rings are continuing to become thinner and thinner. And I think it's probably in early December, they're going to be at their thinnest point. So this is kind of cool to watch as those rings get thin. And then in the spring, they're going to pop back open again. One other thing, we're no longer seeing Titan, the largest moon on Saturn. Its shadow transits are now over till another 14 years. However, the moon itself will be visible cutting across the planet. And the next one for that is October the 21st, starting at 7:15 p.m. and going till a little bit after midnight. So again, perfect timing for our area. Put that one on your calendar for a couple weeks from now. And you should be able to see, that might be a little harder to see than a shadow transit, but you'll definitely see, because of Titan's lower albedo, you should be able to see like a dark little ball crossing in front of Saturn. Next. And if it's October, we've got the Orionids. This year, if you click again, is really going to be a fairly good year. They normally produce roughly 20 meteors an hour. Of course, light pollution and your sky transparency is going to have a lot to say about how much you see. The peak is on October the 20th, 21st. Again, the October the 21st, you might as well just stay up and start with Saturn and end up with the Orionids. Early morning again for most meteor showers. There is a new moon, so that's ideal in terms of you don't have to contend with moonlight giving you some light pollution. One more. And we happen to have comets in the sky right now. We have Swan, C225R2. This is visible in the southwest after sunset, beginning in mid-October. It's not extremely bright, but it's still technically naked eye if you're at 6 magnitude. So it's going to be cutting across Libra and Ophiuchus. Charts are in Sky and Telescope. One more. And then there is Comet Lemon. That one's going to be visible in the northwest, kind of below the Big Dipper. So it actually may be a little bit easier for you to find. And it's also going to be a bit brighter. They're hoping it might get up to 3rd magnitude. Again, October 21st. Let's hope it's clear, October 21st, which is when it has its closest approach to Earth. If you have a sea star, this is a great, great item to target over the next couple of weeks. And that is your shallow sky for this month.
Awesome. Thank you so
Quick
much.
question, Jim.
Yeah,
We're talking about the other night at the star party. Is there a point, like people try to catch the, the first crescent moon? Is there a point where Saturn blinks out, and is that a momentary thing? Meaning that the rings blink out, and literally that they're edge on, and
they are so thin that if you get to the point where it's totally edge on, they disappear.
But is that like 5 seconds thing?
Oh,
Or
no, I think
overnight?
it's like a day or two. I think
Okay.
it's not momentarily.
Gotcha.
It's not like an occultation. So yeah, it would last well. However, Saturn was too close to the sun in May, so we missed it this time around. So you got to hang in there for another 14 years, Joel.
Oh, we've already gone right that. We've passed the edge on. Okay.
Right, and it's interesting dynamics in that currently the rings are beginning to tilt and we're seeing more and more the southern side of Saturn. If you looked in the sky in Saturn, if you were sitting on Saturn, you would see Earth is kind of like dipping down low in the Saturn sky below its equator. And so it's the dynamics of Saturn, Sun, Earth, and the fact that we're kind of like dropping below, it's making those rings from our vantage point, we're kind of like crouching down and we're seeing, them
Right.
low. After January or December, all of a sudden, we're going to start heading north in Saturn sky, and those rings are going to pop open.
Gotcha. Thank you.
Okay, thanks. Wayne, are you,
How are we doing on time?
8:44?
Yeah, but I don't know how many images you got to show.
A lot, and a lot of
Let's
times.
skip. Let's skip. I'd rather people see the images than listen to me. Yeah.
Oh, okay. Can we at least make the noise, the newspaper turn the boop, 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 boop noise or something? All right, never mind. Okay, well, thanks for that. We'll just move on and maybe do that next month. So back to the images, our last section here. Harini, are you on?
Yes, I'm on.
Can you tell us about this picture? It looks like you did it with a sea star.
So I took this on October 7th, and it was a supermoon that day, but you can't really see it because it actually the telescope zoomed in. So then you can't really tell whether it's a regular moon or a supermoon. It was actually really big for the naked eye, and I learned that the supermoon happens when it's at its closest point to the Earth, which is the perigee.
Excellent. And your sea star got a very, very nice sharp image. And that looks like it was 2 days after our star party, which was, it was pretty full then. You really caught it right at the peak there, a full moon. So thank you for sharing that.
Thank you.
Steve Gauss, are you on?
Yes. This was the Titan transit that we talked about earlier that happened on the 5th of October. And as you can see, that is the moon. The shadow is actually above Saturn. And the moon, I was a little surprised that the moon was so dark against Saturn's surface. But it shows you how bright Saturn is compared to the brightness of Titan itself.
Wow, nice. And this is with a big SCT, right?
Yeah, 14-inch SCT.
Right.
Yeah.
Oh, yeah, here it is. And speaking of Comet Lemon,
Right. I haven't been able to see it with binoculars yet. But I did get it on October 4th, and then I was actually out this morning and got it. I sent that image to the group this morning. This was at the one this morning was at 6 o'clock, so it's actually it's still dark then, and it's up fairly high at that point. You can see some structure in the tail. And it's moving towards the north, actually moving behind a tree in my yard, so I won't be able to get it much longer.
this was a pretty short exposure then, this thing. This
Oh, let's see, 8 seconds.
nice.
Yeah, I think these were 16 frames of 8 seconds each.
Okay.
So it's not moving, it's actually not moving fast enough to blur the stars at that exposure.
Okay, cool. Thanks.
This was a sea star?
No, that was with a 14-inch Schmidt-Cassegrain.
How did you get a 14-inch Schmidt-Cassegrain to do F2?
Sorry?
Hyperstar on the front.
Oh, Hyperstar on the front?
Yeah, I'm
Okay.
assuming you use.
Yeah, that's the Hyperstar on the Celestron C14. Yeah, that gives about a 2-degree field of view.
That's incredible.
I did get it at F11, but it's pretty it's much nicer at this short focal length.
Yeah.
This,
Always focus.
this was not with the Hyperstar.
That's right. That's right.
Okay, let's move on. So, Gary, is this with your homemade?
This is with my homemade scoop. I usually call it a Herschelian, and it's probably more properly called an off-axis Newtonian. It's unobstructed 10-inch, basically.
Really?
10. And I was happy to see this because I'd missed all the previous ones this year, except for one, which was a very bad seeing, and I was barely seeing the shadow going in and out of the turbulence. But here I was really impressed. Titan, like other people mentioned, is shows up very nicely. It's very dark in front of the cloud tops, and then the shadows just grazing along the northern pole there.
So the shadow's right here, huh?
Yep.
Shadow, yeah.
That's awesome.
Wow.
Nicely done.
So, I don't want to derail this, but Gary also made a binocular telescope.
Oh my goodness.
Let's geek out about that after the talk.
You know,
brought-
Just a comment. This was taken late after I had finished my series earlier, and you can see the shadow just skimming the top. And I didn't realize that was going to happen. I didn't stay quite long enough to get that.
Oh, yeah, right.
Are there 2 moons off to the left of the rings?
I believe there were that night. Yeah.
Rita's a little smudge to the upper left. I didn't really try to process it to show up well, but then I think it was Dione maybe.
Okay. There's a second one farther out. It's a lot fainter. I almost have to use averted vision on my screen.
Oh, yeah, like up in the, I can see it on my computer screen, but not on the monitor. And Jim,
Okay, that was Jupiter from October the 2nd. You would think that is a shadow transit, but actually that is Callisto, kind of keeping on the theme here of, you know, if a moon has a low albedo value compared to the cloud tops of the planet, it's going to show up dark. And that's much different than the other moons, the other 3 Galilean moons, which usually almost kind of blend in and they can kind of be hard to see. So the red spot's back, it's hanging in there. A couple little ovals to either side of the red spot below it are some long enduring anticyclone storms. Just always Jupiter, favorite planet to image. Lots going on.
Nice.
Okay, and this one was Saturn. Took an image again. This was the 19th. It's a few days before, a couple days before opposition, which I think was on the 21st. And at opposition, there's something called the opposition surge or the Seeliger effect, which basically all of a sudden for like a day or so, the planet brightens, and especially the rings, because you get this backscatter. Thank you. And so for comparison, I took one of my images that I took earlier in the season on July 24th, cut it in half, and then put the one on the 19th. And you can really see the difference of that opposition surge. That's probably the best example of it that I've ever been able to acquire. So you
Wow.
can see that the right-hand side there, 2 days before opposition, those rings really are shining a lot of light back from the backscatter effect.
Wow,
Cool. Cool
that's
beans.
fantastic.
Thank you.
Yeah.
And then I got up early again, same day, the 19th, and ran out to Loch Raven Reservoir for the triple conjunction with Regulus, Venus, and the crescent moon. That was just gorgeous. I mean, you know, not everything high-powered, big telescope. This just basically enjoyed with binoculars and the Canon camera taking some shots of it.
Cool.
Just amazing, you know, totally lined up in a row. It was just absolutely gorgeous.
Were you over what? Is this water?
Yeah, that's the reflection in Loch Raven.
Nice.
What kind of camera was it?
A Canon with a standard kit lens at about 200 millimeters.
Nice. Nice. Richard Orr, are you on? So Richard, you know, now for something completely different. Richard likes to draw at the eyepiece. He's got a nice 6-inch refractor and he gave us a presentation fairly recently on his technique, but he likes to hand draw what he sees. And so I don't know what to say about this other than it's pretty cool. And he's got Titan way over here and some of the moons. And he submitted another one as well, in the spirit of the transits. Yeah, I wish he was here to talk about this because this is just so cool. I don't know how long it takes him to do this, but let's move on. And then Rich Friedrich, are you on, Rich? This, I think, was Rich's first submission of his, this is M15. It's a very nice shot there. Steve Royal, speaking of sea stars, Steve, are you on? Steve submitted a whole bunch of things that he captured with his sea star. And then last but not least, Jose, are you on? This Jose is really one of, I mean, I don't know, I no longer consider him a noob. He's somebody who started his astrophotography journey really not that long ago. So this is quite impressive that he was able to do this.
Has he ever talked on that?
On
Starting an astrophotography journey?
no, maybe we can get him to.
That would
We
be
have a
really
number
interesting.
of astrophotographers that do deep sky stuff that could give a talk on that. So we used to do something called Astro School where we had things like that. Maybe we'll have to pick that up again. So that's it. That's all we have. We have 5 minutes. Sorry.
And with this Thursday evening, changing to this second Thursday with, in concert with the Bird Club, next door. It is not as much, yes, we are finishing up at 9, but it is not as much hard stop. Like we need to be at the front door at 9. So just as long as we're wrapping up around 9 and filtering out, we're in good shape.
Okay, great.
I
So
think
I
our
think
new-
that-
Our new MOU is actually gonna say 9:30 at the
Yeah.
building.
Oh, right.
So I think we're gonna maybe turn the lights up and maybe take a look at some of the stuff that Guy brought. I'll leave, I'm gonna stop the recording, but I will leave the camera on and I'll just move the camera over so you can see what we're seeing if anybody wants to stay online. So for those who have to go, thank you guys so much for coming for our meeting, and thank you, Guy, for our speaker, and thank you guys for coming out. So
I'm very impressed by the astro photos I saw just now and drawings.